Hey everyone, and welcome to This Explainer. If you're currently gearing up for your exams and feeling, well, maybe just a little bit overwhelmed by all those complex economic models, you are in the exact right place. Today, we're going to act as your ultimate jargon-free revision guide for general equilibrium theory. Look, I know the math and the concepts can seem super intimidating at first glance, but I promise you, by breaking things down in simple language, it's all going to click together perfectly. So let's dive right in and demystify exactly how a whole economy balances out. Okay, here's our revision roadmap for today. 1. Beyond partial equilibrium. 2. The pure exchange economy. 3. Reaching Walrasian equilibrium. 4. The math behind Brouwer's theorem. 5. Adding production to the mix. And finally, 6. The 3 big efficiencies.
All right, let's kick things off with Section 1, Beyond Partial Equilibrium.
So to truly grasp the big picture of an economy, we absolutely have to look past isolated markets. Up until now in your studies, you've probably spent a lot of time on partial equilibrium. That's basically looking at one single market in a vacuum. For example, if people's income goes up, they demand more agricultural products. Simple, right? But general equilibrium steps back and says, wait a minute, that increased demand for crops means we suddenly need more farm equipment, more seeds, and more farm workers. It causes this massive ripple effect. General equilibrium is all about mapping out those interdependencies and watching the simultaneous interactions of all these markets happening all at once.
Moving right along to Section 2, the pure exchange economy.
Now, to figure out how all these interacting markets actually find balance, economists love to start incredibly simple. We're talking a world with absolutely no factories. Let me act as your translator for this concept. A pure exchange economy is just a model where nothing new is manufactured at all. Zero production. People just show up with an initial bundle of goods, which economists fancy up by calling endowments, and they just trade them based on what they actually want to consume. It's quite literally the absolute simplest building block of our economic model.
Picture this, you've got a huge basket of apples, and I have a basket of oranges. Now, if I happen to prefer apples and you prefer oranges, we're going to enter into an exchange. We trade our goods at a specific exchange rate or relative price, and we keep trading until we're both perfectly happy with our new mix of fruit. Honestly, this apples and oranges analogy is a highly tangible, memorable mental image to keep locked in your head for revision.
And that brings us to a crucial rule, perfectly captured in this quote from the source material. In the equilibrium, the aggregate demand cannot exceed the endowment. In plain, simple language, you just cannot buy or consume more than what physically exists in the economy. This is a bedrock rule of the Walrasian equilibrium. The total amount of apples and oranges rolling around after our trading session has to equal the exact total amount we started with. No magic fruit appearing out of nowhere.
Okay, Section 3, Reaching Walrasian equilibrium.
So, how do we actually find that perfect exchange rate? How do buyers and sellers settle on the exact prices that clear these markets so that absolutely everyone is happy and there's nothing left over? Your textbook likely uses this formula, the excess demand function. Sure, it looks a bit math-heavy, but let's translate it into plain English right now. ED just stands for excess demand. D is demand and S is supply. So all this formula is telling us is that excess demand equals demand minus supply. And equilibrium, that sweet spot of perfect balance, happens when this equation equals exactly zero. That means zero excess demand and zero excess supply. Everyone gets exactly what they bargained for.
But practically, how do we push that excess demand down to zero? The source outlines 3 different mechanisms. You've got provisional contracts, where buyers and sellers make conditional agreements before actually trading. You've got central planning, where a central authority collects all the data to set prices. But the most famous one by far is the Tatman process. For this one, picture a fictitious auctioneer standing in the middle of a grand market square. He shouts out a price for apples. If way too many people want apples, he raises the price. If nobody wants them, he lowers it. He keeps adjusting dynamically until demand exactly equals supply, and only then does the actual trading take place. It's totally theoretical, but man, is it an effective way to visualize how prices settle.
Now for Section 4, the math, specifically Brouwer's theorem. Okay, I need you to take a deep breath here because we're moving on to the heaviest mathematical concept in this block. But don't worry, we're going to look at it purely visually to make sure you totally nail it for your exam. This is Brouwer's fixed point theorem. In simple terms, economists needed a way to mathematically prove that this magical equilibrium price, the one where excess demand is zero, can actually exist in reality. Notice how the continuous function curve perfectly intersects the 45-degree line. That specific intersection represents a fixed point. And that intersection is the ironclad mathematical guarantee that a set of equilibrium prices definitely exists in our model. If the curve is continuous, it literally must cross that line.
All right, on to Section 5, adding production to the mix. So now that we've mastered our pure trading economy and proved it works mathematically, it's time to shift gears. We're stepping into a much more realistic world where goods aren't just traded, they actually have to be manufactured. To do this, we're upgrading the model. We're adding two key inputs, capital, which we represent with a K, and labor, represented by an L. And instead of just swapping apples and oranges, our economy is now utilizing that capital and labor to produce two final goods, food, which is F, and shelter, which is S. This entirely sets up the foundation for the final stretch of our revision guide. Now, think about how real-world production differs completely between industries. Producing food is generally very labor-intensive. That means it demands a lot of workers relative to the amount of machinery used. On the flip side, the shelter industry is incredibly capital-intensive. It requires way more machinery and raw materials per unit of output than it does human labor. This contrast creates a beautifully complex, highly interconnected web of demand for different resources rippling across the entire economy.
And finally, Section 6, the three big efficiencies.
This brings us to the grand finale of general equilibrium with production. For this complex web to reach a state of perfect harmony, specific conditions have to be met simultaneously. There are three major efficiencies you really need to master for your exam. First up is allocative efficiency, also known as efficient consumption. Here, our scarce inputs are the finished food and shelter, and the ultimate goal is consumer utility. This efficiency is achieved when the marginal rates of substitution, which is just the rate at which consumers are willing to trade food for shelter, are perfectly equal for everyone. Second, we have productive efficiency. In this case, the scarce inputs are capital and labor, and the outputs are the actual food and shelter. Achieving efficiency here means the marginal rates of technical substitution are totally equal across all sectors. Put simply, producers can't just shuffle labor and capital around to magically make more food without being forced to sacrifice some shelter.
But hold on, because there is a third, vital piece to this puzzle: product mix efficiency. Think about it. You could be producing food and shelter incredibly efficiently, and consumers could be trading them back and forth efficiently. But what if you've produced 1 million units of food and only one single unit of shelter, and people actually really want houses? Product mix efficiency ensures we completely avoid this trap. It states that the marginal rate of product transformation, the rate at which the economy can physically shift its production from food over to shelter, must perfectly align with the price ratio consumers are actually willing to pay. In short, we absolutely have to produce what people actually want.
When we map this whole thing out, from the fictitious auctioneer calling out prices, to Brouwer's fixed point, to matching productive capabilities with consumer desires, the sheer elegance of the general equilibrium model is honestly breathtaking. But it leaves us with a rather provocative thought to chew on for your exam revisions. If perfect efficiency requires all these incredibly specific stars, allocative, productive, and product mix efficiencies to align absolutely perfectly across every single market simultaneously, how close does our messy, chaotic, unpredictable real-world economy actually ever get to it? Keep that question in the back of your mind as you continue your studies. Thank you so much for joining me on this explainer, and happy studying.